guys, welcome back to my channel. Today we're going to talk about something very unique. We're going to talk about this. Well, it doesn't look so clean, but you can see what this is. This is a pressure cooker. It's called stove top type. It's a steel type of pressure cooker. It's made of steel. Forgive, it's dirty, it doesn't matter. It's my stove, it's my pressure cooker. Now, just before we can proceed, we're going to try to name it. We're all familiar with this. It's found in every kitchen across the world, so there's nothing really new, except maybe you've never asked how it cooks the food so fast. So let's start by naming the parts. Okay, I'm taking off the lid, and this is what you call pressure regulator, and then below here we have the steam vent tube. You can see there's a small hole here where the vapor goes through when the pressure accumulates. And then we have, this is the lid itself, and this is the gasket. Yeah. This is I guess air plug. Okay, or pressure plug, I don't know, whatever you call it. See, so this is the body itself. This is a cooking rack. It's an old one, so I hope you won't mind. This is the handle, the lid handle. Okay, and this part has come out, but here we have studs and screws before for body handling. Now I use a piece of cloth to handle it, and here we have subsidiary handle. It's also gone. It's an old pressure cooker. So today we're going to talk about how this great invention, kitchen invention, cooks food so fast. Let's start by the formula. There's something called gas law, ideal gas law, and this ideal gas law states that, sorry, I don't know whether you'll see it the right way from there, I don't know, but this is pressure volume is equal to nRT. Here it looks inverted. This stands for mole, amount of substance. This is ideal gas law constant, and this is temperature. This is an equation for pressure cooker. Okay, so pressure times volume is equals to N, which stands for amount of substance, times R, which is ideal gas constant, times temperature. This is maths. So from this you can calculate the pressure, volume, temperature. Yeah, if you are a mathematician. So how does the pressure cooker cook food? Let's talk about sea level. Water boils at 100 degrees centigrade at sea level. That's 14.7 psi pressure. Okay, so when you put food inside the pressure cooker, first of all, why is it called pressure cooker? Let's just analyze the pressure itself. What is pressure? Pressure is the force exerted on a physical body. the force, the stress is called pressure. And how does it develop? Well, if it's inside a pressure cooker, for example, and you have closed the lid, the molecules, and you put the heat, the molecules will run up and down, collide to each other. And if molecules, you don't understand what it is, molecules are made from atoms. And atoms, an atom is the smallest indivisible particle, right? Which can, the smallest indivisible particle, and an atom consists of nucleus, protons, electrons, neutrons. So protons and electrons have charges, like protons have positive charges, electrons have negative charges, and neutrons have no charge. So these bond together to form molecules in nature, and there's something called natural frequency. They form bonds which vibrate. Now these molecules run around when you put the heat, okay? And they gain enough energy to escape from the liquid and form something called gas vapor, steam vapor, which has thermal energy, okay? So when you put food inside the pressure cooker, this steam that forms above the food is what cooks this food so fast. Now, so what happens? So the pressure will increase when you heat, the temperature will increase. As the pressure cooker gets more heated, the temperature goes up, the pressure goes up. And the pressure, once inside the pressure cooker, you have 15 psi additional to 14.7. That means it can go up to 30 psi pressure. And the boiling point will increase to 121 degrees centigrade, or 250 or 249.8 to be precise Fahrenheit. And at that temperature, it's very hot and the food will cook faster. Okay, let's talk about a scenario where, for example, you gain altitude, you go up higher than the sea level. So what happens? What happens is that for every 500 feet or 142.4 meters high, the pressure drops, the degree centigrade drops by 0.5 degrees. Means the boiling point goes down from 100, below 100. So below 100 means that the food will take longer to cook because there's less temperature, right? So the pressure cooker is very ideal to use in high grounds, in high altitude, like highlands, higher than the sea level, because it compensates for that loss of, the higher you go, the less the pressure becomes, compensate for the loss of pressure and heat, okay? So that's how this thing works. It works through pressure. You put water, it forms steam, and the steam cooks the food. So what are there any risks in using this? Of course, it depends on the manufacturer or how it's made. I mean, if there are some defects, then the risks are there that it can blow. But what will come out is what you just put inside. If you put petrol inside, then petrol will burn. But what you have put inside is water. The steam will eject. It's something rare. So, which are the best pressure cookers? I mean, there are all types of pressure cookers. We have aluminum type, we have steel type, we have electric ones. But each has trade-offs. Like when you use aluminum, it cooks faster, but there is leak and leach. I mean, it leaks. It's difficult to clean it. Unlike the steel one, like this one is easy to clean, and it has high heat retention. Okay, and electric ones are good also, better than this, because they are portable. Yeah. and it depends on which type of pressure cooker you are using. Yeah, the prices are also different. So you can see from this that you can calculate, for example, if you want to know what amount of pressure is inside the pressure cooker, you can, I don't know whether I'll show you this mathematically. Hold on a minute. I'm gonna show you this maths. Mathematically, you can calculate this like PV. I don't know whether you see this. PV is equal to nRT. This is maths. Now suppose you want to know the pressure, you will divide by the volume. So volume will also pressure. Pressure will be equal to amount of substance times R, which is the constant, gas law constant, times temperature. So this will be divided by volume. So you can see that you can, from this maths, you can calculate the pressure inside your pressure cooker with this, and you can also calculate the temperature or volume and stuff like that. So guys, it's all to say about this thing, this very famous cooking vessel called pressure cooker. Forgive for the dirtiness, it has gained some stains. It's an old one. Okay guys, this was a pre-video. I want to talk about this very famous master of the kitchen stuff on the pressure cooker. Hope to see you again. Thanks for watching. Bye.